We'll be speaking about applications and processing of algae bioplastic. Our speaker is Dr. Bruno Ferreira, CEO of Biotrend.
Hello, good afternoon. First and foremost, thank you so much for the invitation to participate in this conference and enable me to share a little bit of our experience in the production of bioplastics using microalgae. So as a disclaimer, I come from a completely different world than has been discussed in the last presentations. I'm definitely somebody that has more than 2 decades of experience in fermentation, so no light involved. But what we've learned and what we realize is that fermentation does need materials that are produced in plants, and that the most productive plants that exist in the world are actually algae. And I will address that. So Biotrend has been an independent company since its foundation, but 3 years ago we have realized that we shared a lot of values and approaches to the development of technology as A4F. And 3 years ago, Biotrend has joined the A4F group of companies. And as you can see, from a technology development point of view, that makes a lot of sense. So in the top, you have the A4F specialties, and in the bottom, the Biotrend core know-how. And we cover, with both companies, several stages from applied research, contract R&D and technology development, and finally transferring the technologies and the processes to commercially relevant scale, both for autotrophic systems, meaning systems that require light to operate and that are able to use CO2, as Luis mentioned, but also the fermentation systems, which do not require light, which do not capture CO2, but which are able to use sustainable and renewable sources, raw materials, in order to grow microorganisms. And this is actually the core technology Now, relating to algae, we don't see ourselves as an algae producer, but as a producer of a specific product in which algae can play a role. So we don't tend to look at the algae at the center, but as a means to do something. And as Louise also mentioned, to choose the right technology, you need to pay attention to a number of constraints and a number of factors. Of course, the product you want to produce, the climate and geography where you want to produce, because that impacts not only the conditions to run the production, but also the raw material that you have available. The social environment, for example, how easy is to have access to the human resources which are required to implement a specific facility and technology, and whether you want to use the whole product or just a fraction of it. And if you just want to use a fraction of it, which is the kickstart of the project, what will you do with the rest of the biomass, leading to biorefining options as well. And now diving into bioplastics. This is a very popular and well-known cover of National Geographic. And you see a plastic which is shaped like an iceberg. And there's a question there, which is kind of a provocation for us to think about, which is planet or plastic? And that makes us think, but I hate the question. Why not planet and plastic? And that's exactly what we're trying to do. Realizing the problems that plastics have brought, but also being very much aware of all the things that wouldn't be possible if plastic didn't exist, which affect our lives. If you think on the food supply chain, for example, which is not only convenient, but deeply necessary to transport foodstuff from one place where the production is feasible to another where it's not feasible. If it wasn't plastic, probably we wouldn't be able to have the food production chain with the quality and safety that we have today. Think only a bottle. A glass bottle is sometimes claimed this is much more sustainable because you can reuse. I bet that people who say that never visited a factory where the used bottles are cleaned in huge machines with sodium hydroxide being sprayed at high temperature, and then all the water that you need to clean up so that the glass can be reused and again and again. And let alone the carbon footprint of the transportation of bottles, of glass bottles back and forth. So plastics are very much useful, and I think the challenge is to try to find a compatible way to preserve the planet's sustainability while still having the convenience of plastic use. And definitely the industry is stepping in, and bioplastics are not a dream, they're a reality. Still a tiny fraction of the plastics used today, but still already a reality. These are numbers which have been compiled by the European Bioplastics Association and reveal already the size of the market, but also some of the aspects which we need to take into account in order to make sure that we know what we're talking about. What's a bioplastic after all? And bioplastics sometimes merge different concepts, like a bio-based plastic, which means a material which has been produced using a renewable resource, and then a biodegradable plastic, which is a plastic that can degrade in the environment. But you can have bio-based plastics which are not biodegradable, and and plastics not produced using renewable resources which are biodegradable. So that's, it does not help in the communication, but that's what it is. But if you look at the projections and in these charts, on the left side of each pie chart you have the bio-based non-biodegradable plastics, and on the right-hand side the bio-based and biodegradable plastics. And if you compare the two pies, you can draw a lot of information, but the main takeaway messages are the bioplastics market is really growing very, very fast. And in a market which is growing very, very fast, the share of biodegradable bioplastics is also increasing. So the growth rate for bio-based and biodegradable plastics is surging, which is good news for us. And I will now provide some examples of our own activity, which are actually based on two different materials: starch, which apparently is in the projection currently stagnant. Eventually that will not be the case, but currently the projections are that starch will stagnate. And I will talk also about biopolyesters, a family of biopolyesters called polyhydroxyalkanoates, which are growing at almost 50% rate per year. And currently, bioplastics are mostly produced using renewable resources that compete with food and feed. So there's arable land which is required today using the current technologies to produce these bioplastics, and that causes a problem. As we were hearing in the keynote, food security is an issue, so it's probably not ethical to grow plants on arable land to produce industrial products, and that's what we're trying to tackle as well. So this is an example of a project which is co-funded by the European Union and which gathers different partners. And what we're trying to do and achieving actually in this project is to grow microalgae in conditions that favor the accumulation of starch in the microalgae. And then we extract the starch and use the starch as sugar source as a fermentation raw material. And during the fermentation, we produce biopolyesters. These biopolyesters are then formulated and used in prototypes for many different applications. As you can see, from food packaging to agro-textiles and cosmetics. So this is a project which is running what we call at research level. But the results have been quite promising. And we've recently launched a larger scale initiative in Portugal in which we will not take only the starch of the biomass. And we'll try to use the whole algae biomass to produce useful products. So it all starts, of course, with the algae cultivation. And again, algae are grown in conditions that favor the accumulation. Then there's a first step of biomass refining, in which we take the starch. We don't need to fully purify the starch. We could eventually fully purify, and there's a partner to use the starch. But we don't need to fully purify the starch. We saccharify it. And then we can use the resulting sugars as fermentation raw material. In complement, the residual biomass can be used as an ingredient in the fermentation, which is successfully replacing some of the most expensive fermentation materials. And so by using both stream starch and non-starch components of the biomass, we actually get an excellent fermentation raw material to produce polyhydroxyalkanoates. And if we, depending on what we do with the residual biomass, we can also tune the fermentation so as to produce a homopolymer, which is a large polymer chain which has only the same motif, the same monomer repeated, or a copolymer of different monomers, and that dramatically affects the mechanical properties of the end product, meaning that brings wide diversity to the potential applications of the product. And this slide actually reflects that. So on the left-hand side, you can see some material which are producing zinc PHB, and you can see the gear on the bottom. It's here, it's still alive. That has been produced, this has been produced 5 years ago. So it's biodegradable, but it's durable. And you can formulate biodegradable materials in order to be durable. And you can feel it, it's tough, it's a solid material. On the right-hand side, you can see a page of a book, and then an arrow. And the arrow points out to a sheet of polymer, very thin polymer, which is transparent and flexible. And this is done using the same technology, using the same base. You take the algae, which captures CO2, which can use nutrients from other activities. You use the carbon and the other components of the algae to ferment and to produce biopolymers which have tremendously different potential applications in durable materials, in rigid materials, in flexible materials, and also in bioadhesives. And this is what we have been doing in the last 10 or 12 years, collecting knowledge in many different European projects. This is not something that you can do alone in your own lab with your own knowledge. You need to take in knowledge from partners, to share your knowledge with partners which have a different skill set. And in the end, you need to have a wide range of partners that know how to process polymers. We know how to do biotechnology. We don't know how to process partners. You need to have end users. You need to know what the customer wants, what's the pain, what's the type of application, what's the regulatory framework that could have an impact on the development of your technology. And going back to this slide, so what are we trying to do is actually take the benefit of some of the most interesting features of algae to solve the problem, which in my view is actually being one of the causes why starch is stagnant. It's stagnant because first and foremost, it's used in the food industry, and arable land is required to produce starch for the food industry. The industrial uses of starch are competing with that and cannot be expanded that much, and it's a low-cost application. With algae, we're not competing with arable land. And if you take the amount of arable land that is forecasted to be used to produce starch and PHA in 2027, that amounts to 435,000 hectares. If you produce the same products but using algae and without breaking any records, you will decrease the area required to 160,000 hectares. And very important, not only you reduce the area which will be needed, but you don't use arable land. I think that's nice. And of course, in order to do that, you need to produce algae in a way that you can produce in large volumes and low cost. So this is why we are partnering very much with A4F, which is testing new concepts for aviation biofuels, and it's the same. So you have a kind of a high-end application, but you need volume, you need area, you need low cost, and you need circularity. So you need, it's very important for us also to develop these concepts in which to use existing streams from existing activities. So if you have a chemical plant with CO2, with liquid effluents that can potentially be used, sometimes these cannot be brought to the production of foodstuff, but they can definitely be brought to the production of plastics, which have an industrial use. And thank you very much for your attention. We are on the booth right on the left and be available to meet you and ask any questions you may have later on. Thank you so much.